Here we discuss what is modular inverse of a number. We know the linear congruence Ax congruent to B mod m is solvable if D equal to Am divides B and it has D number of incongruent solutions. Now let us take a special case of this linear congruence where B equal to 1. That is Ax congruent to 1 modulo m. Now by the same argument it is solvable if Am divides B, that is 1, that is if Am is equal to 1. So consider the linear congruence Ax congruent to 1 mod m with Am is equal to 1. So it is solvable, that means it has a unique solution, and that solution X is called the inverse of A modulo m, denoted by A inverse. In other words, if A and B are any two integers such that AB congruent to 1 modulo m, then B is the inverse of A modulo m. For example, 7 into 8 is congruent to 1 mod 11 because 7 into 8 is 56 minus 1 is divisible by 11, and therefore we can say 8 is the inverse of 7 modulo m. M is 11 here, modulo 11. That is 8 congruent to 1 mod 11 is the inverse of 7 modulo 11, and it is denoted by 7 inverse. Some cases may be such that A into A may be congruent to 1 mod m. In that case we say A is self-invertible or inverse of A is itself. For example, 10 into 10 is congruent to 1 mod 11 because 10 into 10 100 minus 1 99 is divisible by 11. Therefore 10 into 10 is congruent to 1 mod 11, and therefore we can say 10 is invertible, self-invertible here. The inverse of 10 is 10 itself. Now using the idea of this inverse, we can solve a linear congruence very easily, and this was the method actually we followed where previously. Now the theorem is this: the unique solution of the linear congruence Ax congruent to B mod m where Am equal to 1 is the least residue of A inverse B modulo m. Let us prove this result. Given linear congruence is Ax congruent to B mod m where Am is 1, and therefore the linear congruence Ax congruent to 1 mod m has a solution, and which is the inverse of A. So let it be A inverse. So multiplying this 1 by A inverse on both sides, we get A inverse Ax is congruent to A inverse B modulo m. That is, X is congruent to A inverse B modulo m. Thus, the solution to linear congruence Ax congruent to B mod m is the least residue of A inverse B modulo m. Let us take an example. The linear congruence 4x congruent to three modulo 5. Suppose to solve 4x congruent to 3 modulo 5. Now here a is 4 here, 4, 5 is 1, and therefore 4 is invertible, and its inverse is 4 itself, because 4 into 4 is only congruent to 1 mod 5. Therefore, multiplying this by 4, we get 4 into 4x is congruent to 4 into 3 mod 5. That is 16x is congruent to 12 mod 5. And the 16x is x is congruent actually x, because 16x you can write as 15x plus x. 15x is a multiple of 5. So this x is congruent. Similarly, 12 mod 5 is the same as 2 mod 5, because 12 we can write as 10 plus 2 mod 5. So x is congruent to 2 mod 5 means any x is in the form 2 plus some 5k or 5t, where t in set. So this is the solution to 4x congruent to 3 mod 5. For t is equal to 0, x equal to 2 is a solution to this. Now, you may be remembering one riddle called Fowl's riddle. If a cock is worth 5 coins, a hen 3 coins, and 3 chicks together 1 coin, how many cocks, hens and chicks totaling 100 can be bought for 100 coins? So this was a problem that was discussed in previous chapter, and this riddle actually generates the two equations in the form x plus y plus z is equal to 100, 5x plus 3y plus z by 3 equal to 100, when you assume there are x number of cocks and y number of hens, and chick cost 3 chicks cost z, so each chick z by 3, 3 chicks. And 5x plus 3y plus z by 3 is the total number of coins, and x plus y plus z is the total number of cocks and hens, chicks. Now solving the riddle is nothing but solving this equations 1 and 2, eliminating this z by between these two equations by multiplying 2 by 3 and subtracting 1, you get 7x plus 4y is equal to 100. It is nothing but a linear Diophantine equation. 3 is clearly a linear Diophantine equation. It yields two linear congruences, of which one is 7x congruent to 100 mod 4, and the other one is 4y congruent to 100 mod 7. Here 7 and 4 are such that 7 4 is equal to 1, and therefore it has a unique solution, and that solution is obtained by multiplying by the inverse of 7, because 7x is congruent to 1 mod 4. 7 is invertible. And its inverse of 7 is actually 3, because 7 into 3 is 21. Is clearly congruent to 1 mod 4. So inverse of 7 is 3 congruent to 1 mod 4. So multiplying this linear congruence 4 by 3, you get 3 into 7x is congruent to 3 into 100 mod 4. This is 21x. 21x you can write as 20x plus x congruent to 300 mod 4. 20x is actually multiple of 4, therefore it is x is congruent to 300 is a multiple of 4, therefore it is 0 mod 4. So any x is of the form 0 plus 4t, which is 4t, where t in z. Here actually x is the number of cogs, therefore t must be at least a positive integer. X is 4t. For t equal to 1, you get x is equal to 4 first. Now when x is equal to 4t, from 3 you get y. From 3, 7x plus 4y is equal to 100. It gives you y is equal to 25 minus 70. Again t is such that 25 minus 7 is t is positive. Now substituting the value of x and y in x plus y plus z is equal to 100, we get 4t plus 25 minus 7t plus z is equal to 100 gives you z is equal to 3t plus 75. Thus, solution to the riddle is 4t, 25 minus 70, 3t plus 75. Take the proper value of t, integer, such that all these are positive numbers. Now let us take some more problems from exercise. Find the least residue modulo that is invertible. Find the least residues modulo maybe 6, modulo 6, let it be 6, modulo 6 that are invertible. Suppose there is a question like this: to find the least residues modulo 6 that are invertible. We know the least residues. The least residues modulo 6 are 0, 1, 2, 3, 4 and 5. Least residue means actually the remainders. When a number is divided by 6, we are getting 0, 1, 2, 3, 4 or 5. Now among these numbers, taking it as A, we have to see whether it is invertible or not. We know A is invertible if there exists a number such that A be congruent to 1 mod 6. Now is 0 invertible? Let us see. 0 into what number is congruent to 1 mod 6? 0 into what number? 0 into any number is 0. 0 minus 1. Minus 1 is not actually divisible by 6. Therefore, 0 is not invertible. Now what about 5? 5 into 5 is congruent to 1 mod 6, because 5 into 5 is 25. 25 minus 1 is 24, is clearly a multiple of 6. So the inverse of 5 is 5 itself. So that means this 5 is self-invertible here. Self-invertible. Now what about the other numbers? Remainders, residues, 2, 1, 2, 3, 4, 5. Is 1 invertible? 1 into what number is congruent to 1 mod 6? 1 into 1, we know, is congruent to 1 mod 6. And therefore 1 is also invertible and it is self-invertible. 1 is self-invertible. Then is 2 invertible? 2 into what number is congruent to 1 mod 6? 2 into 3, no, 2 into 4, that is not invertible. 2 into 4, so the least residue modulo 6 that are invertible are only 1 and 5, and they are self-invertible also. In the place of 6, suppose it is 7, or finding the least residues, modulo 7 that are invertible. The least residue modulo 7 are actually 0, 1, 2, 3, 4, 5 and 6. You can see that 1 and 6 are self-invertible, because 1 is congruent to 1 into 1 is congruent to 1 mod 7. 6 into 6 is also congruent to 1 mod 7. Therefore 1 and 6 are invertible and they are self-invertible. 2 and 4 are invertible, because 2 into 4 is congruent to 1 mod 7. 3 and 5 are invertible, because 3 into 5 is congruent to 1 mod 7. So all the numbers except 0, 1, 2, 3, 4, 5, 6 are actually invertible. Among these, 1 and 6 are self-invertible and the others are pairwise invertible. And we will study a property of such things later when P is a prime number. Here 7 is a prime number, so that we will be seeing in Wilson's theorem. That section we will be discussing it. Now let us take another problem to solve a linear congruence by using the idea of inverse. Solve 5x congruent to 3 mod 6 using the idea of inverse. 5 and 6 are such that 5 6 is equal to 1, and therefore 5x is congruent to 1 mod 6 is solvable, or 5 is invertible, and it's self-invertible because 5 into 5 is actually congruent to 1 mod 6. So multiplying this given linear congruence by 5 on both sides, you will get 5 into 5x is congruent to 5 into 3 mod 6. 5 into 5x is 25x. 25x you can write as 24x plus x, congruent to 15 mod 6, and therefore this x is congruent to 15 mod 6, and 15 again you can write as 12 plus 3 mod 6, and therefore it is congruent to 3 mod 6. Thus any x is in the form 3 plus 6 t, 60. So a solution to 1 is in the form 3 plus 60, that t is an integer.